The human brain is a physical object. Atoms and molecules within it obey the deterministic laws of physics, meaning every thought and decision is governed by chemical reactions and electrical pathways, operating like a complex machine. This graph plots the electrical behavior of a single ion channel. Traditionally, science interprets behavior in two ways: strict determinism, a predictable response to a stimulus, or the random flickering between open and closed states seen here. Rigid chemical dominoes and microscopic randomness leave no room for human agency. Consequently, many scientists argue that free will is a complete illusion. In the 1980s, neurologist Benjamin Libet designed an experiment to find out exactly when a human consciously decides to act. He used an EEG to monitor subjects as they noted the precise moment they felt the urge to move their finger. Libet identified a readiness potential, a spike in brain activity preparing for movement, occurring 0.4 seconds before the conscious urge to act. 0.4 seconds is an ocean of time in neurology. It suggests the unconscious brain initiates our choices long before our conscious minds are even aware of them. This frames humans as passengers in their own bodies. But solving this paradox requires looking past human subjects and observing what happens when an animal stops in its tracks. The 1930s behaviorist view of the mind argued that animals are biological vending machines, outputting a strictly predictable response for every sensory stimulus. Psychologist Edward Tolman tested this rigid view by studying how rats navigated physical mazes. Reaching a T-junction, the rat stopped, looked left, looked right, and physically hesitated. Tolman called this vicarious trial and error. He proposed the hesitating rat was lost in thought, internally testing hypotheses about which path to take before committing to a physical move. Tolman argued this hesitation proved that brains build internal maps to weigh future options, a conclusion that ran directly against the behavioral dogma of the 1930s. Modern neuroscience provided the mechanism for Tolman's theory when John O'Keefe discovered place cells in the hippocampus, a finding that won him the Nobel Prize. These cells fire an electrical signal only when a rat occupies a specific physical location. This graphic maps place cell activity. The top shows cells firing sequentially, 1, 2, 3, 4, tracking physical movement. But on the bottom, when the rat hesitates, cells for both paths fire. The stationary animal's brain is sweeping forward through possible routes. In other words, the rat brain runs a rapid, virtual reality simulation of future consequences to select its next move. This biological simulation allows us to reevaluate Libet's experiment, where the unconscious brain appeared to decide 0.4 seconds early. Research from 2012 proved the readiness potential, this large downward slope, is a statistical artifact created by averaging data. The wavy line at the bottom shows real-time activity. Libet's slope is actually just the natural ebb and flow of background brainwaves hitting high excitability. Consciousness acts as the active, highly excitable arena where all these internal simulations are finally judged and executed. We can define free will through the lens of deterministic chaos. Billions of neurons in your head obey physical laws, but they interact in massive feedback loops that create unpredictable outcomes. These loops allow the brain to process information autonomously, generating its own dynamics rather than just reacting to external cues. This process enables the brain to temporarily disconnect from the outside world to run complex simulations using memory and imagination. Free will represents the biological capacity to deliberately deliberate. The outcome of a decision is the product of your specific internal cognitive map, the unique web of your memories and values. This biological uniqueness forms the basis for how we assign accountability. This creates a clear distinction between a thoughtless reflex and a premeditated act. When the entire system pauses to simulate the future, the responsibility for the act rests with that system. The next time you find yourself at a crossroads, agonizing over a decision, remember that this very hesitation is the physical mechanism of your freedom. It is a profound biological marvel, first recognized by watching the simple hesitation of a rat in a maze.